Hi, welcome to week 2 of Stat 221 Monte Carlo Methods based on Sage. I'm Raz, your lecturer. This is the actual course webpage, and this is lecture 2.1, so we are on week 2, and our topic is maps, functions, collections, and probability. So go to the Sage server, the Maths and Stats Sage server at the University of Canterbury. Log in. Once you've signed in, you can grab a fresh copy by going to the published worksheets and grabbing Stat 221 Week 02 worksheet. Once this is processed, hit Edit a Copy button on the top left. And now you should be staring at your own copy of the worksheet, Week 02. So in the last worksheet, we talked about sets. Remember, a set is a collection of distinct objects. Now, a map or a function is a specific kind of relation between two sets. These two sets are traditionally called the domain and the range. The map or function associates each element in the domain with exactly one element in the range. So more than one distinct element in the domain can be associated with the same element in the range, and not every element in the range needs to be mapped. That is, not everything in the range needs to have something in the domain associated with it. Here is a map for some family relationships. Raz, that's me. I have two daughters named Anu and Ashu. Jenny, your tutor, has a sister called Kathy, and the father of Jenny and Kathy is Jonathan. We can map these daughters to fathers with the Find Fathers map below. The daughters are in the domain, which is the set here on the left, and the fathers are in the range, which is the set here on the right. Each daughter maps to a father. Anu is mapped to Raz, and this arrow is the mapping. And Jenny is mapped to Jonathan. More than one daughter can map to the same father, like Anu and Ashu are being mapped to Raz, and Jenny and Kathy are being mapped to Jonathan. The notation for this mapping would be find father's map, colon, daughters to fathers. This arrow is 2. The domain is the set daughters equals the set containing Anu, Ashu, Jenny, Kathy, and the range is the set fathers, which is the set containing Raz, Jonathan, and Fred. Okay, look, here is Fred. Fred has no daughters. The element in the range that an element in the domain maps to is called the image of that domain element. For example, Raz is the image of Anu in the Find Fathers map. The notation for this is Find Fathers map of Anu equals Raz. So this parentheses here is said off typically. Note that what you have just written is a function, just like the more familiar format of f of x equals y. In computer science lingo, each element in the domain is called a key, and the images in the range are called values. The map or function associates each key with a value. The keys for the map are unique since the domain is a set. It is a collection of distinct elements. Lots of keys can map to the same image value. Like Jenny and Kathy have the same father, Anu and Ashu have the same father. But the idea is that we can uniquely identify the value we want if we know the key. This means that we can't have multiple identical keys. This makes sense when you look at how the map works. We use the map to find values from the key as we did when we found Anu's father above. if we had more than one anu in the keys, we could not uniquely identify the value that maps to the key anu. We do not allow maps or functions where one element in the domain maps to more than one element in the range. In computer science lingo, each key can have only one value associated with it. So the picture below is not a function. Formalizing this, a function f going from the domain x to the range y, note that the domain x is a bold capital X and the range set is y, bold capital Y, is equivalent to the set of all x comma f of x such that x is in the domain and f of x is in the range. Now this x comma f of x is called an ordered pair because it's a pair, it's got two elements in it, and there is an ordering to it because the first element in the ordered pair is an element of the domain and the second element in the ordered pair is its image in the range. Now the pre-image or inverse image of a function f going from x to y is denoted by f superscripted by square bracket containing -1. This is called f inverse. The inverse image takes subsets in the range and returns subsets in the domain. So the pre-image or inverse image of y is f inverse of y, and it's nothing but the set of all x in the domain such that f of x equals y. And clearly this set is a subset of x, or the domain set. For example, for a find father's map inverse of Ras is the set Anu and Ashu. And find father's map, the inverse image of Jonathan, is Jenny and Kathy. Now let's take a more mathy looking function, f of x equals x squared. So version 1 of this function is going to have a finite domain. It's only going to have 5 elements. So the domain now is the set -2, -1, 0, 1, and 2. And the range is the set 0, 1, 2, 3, and 4. The mapping for version 1 of this function is f of x equals x squared, and it goes from -2, 1, -1, 0, 1, 2 to 0, 1, 2, 3, and 4. And the picture looks like this. The square of -2 is 4. Square of 2 is also 4, and so on. We can also represent this mapping as the set of ordered pairs -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Note that the values 2 and 3 in the range have no pre-image in the domain. This is okay because not every element in the range needs to be mapped, right? Having a domain with only 5 elements in it is a bit restrictive. How about an infinite domain now? So we'll look at version 2 of our function f of x equals x squared. This time the domain is the set of all integers. So the ... here means all the negative numbers to the left of -2, and the ... here means all the positive integers to the right of 2. And the range clearly is 0, 1, 2, 3, 4, ... As ordered pairs, we now have ... -2, 4, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, ... Of course, it's impossible to write them all down since there are countably infinitely many elements in the domain. Well, let's look at version 3 of this function. What if we wanted to use the function for the whole of the real line R? So this is the blackboard font R. It represents the real line. So f of x equals x squared goes from R to R, from the reals to the reals. Clearly, we don't even want to attempt to write down, even with ... dots, the set of ordered pairs represented by this function because there are uncountably infinitely many elements now. This is a good time to pause the video and go back and recollect these notations and definitions and I'll see you in lecture 2.2.